Interference. In the previous chapter, we described interference, how waves interact depending on their phase differences. The way sound waves interfere affects what we hear. So we had the in-phase or constructive interference, where their maxima occur at the same time and their minima occur at the same time, so they just reinforce each other and you get a bigger signal. Completely out of phase, there we have a maximum interacting with a minimum that equals 0. And you just go along the wave and you get nothing. They add destructively. If you're a little bit out of phase or a lot of bit out of phase, but not completely out or in, you get a partially adding condition. So you get a smaller wave. If two sources, and here's our sources, the green and the black speaker, they emit the same wavelength sound and the waves travel the same distance to the listener, they'll constructively interfere and the combined sound will be louder. In this case, the crests meet up like that, the troughs meet up like that. So hopefully you can see that in the picture now that I circled it. Maybe you didn't even need the circling part. But over here, we're going to define this as our path length. And our wavelength starts here, and you have to go to where it starts repeating again, which is right there. So that is one full wave. So this we're having constructive interference. But what if the two sources emit the same wavelength of sound, the same frequency of sound, the same note, and the path length to the listener is different by 1/2 of a wavelength? Then the waves are totally out of phase. The crest of one wave will meet the trough of the other, and the waves will cancel each other out. And the best way right here, you can see that happening. Right? Here's a crest. Here's the trough. They add together, you get 0. So you have destructive interference. If the amplitudes are the same, of course, like you see below, the two waves will cancel completely and no sound will be heard. So what have we done here? We've changed the path length between the two speakers. They have different path lengths to the listener. And in this case, the listener won't hear anything, at least at that particular wavelength. But what if we move the sources or the speakers again so that the path length, the difference from this speaker to the listener, is 3 lambda, and the other path length from the other speaker is 2 lambda. So they're now 1 lambda apart, right? 3 minus 2. Look at this. The maxima all occur at the same point, and so do the minima. So we have constructive interference. So the combined sound of the two speakers will be louder. This is the same result as when the waves were traveling the same distance, except when you're at 3 lambda and 2 lambda like this, it will be louder because this speaker is closer than it was back here. So this slide is kind of repeating what I said on the previous slide, which is good. It's an important point. If two sources emit the same wavelength sound and the difference in path length is an integer multiple of lambda, that is 1 lambda, 2 lambda, 3 lambda, the two waves will constructively interfere. The combined sound will be louder.